Hi class, this is Mrs. Lyons. The purpose of this video is to help you understand what a mole is and how we use the mole in chemistry. The mole is a number. Whenever we refer to a mole, we're referring to a number. And I want you to kind of think about this. If I said to you, what is a dozen? Say I have a dozen cookies or a dozen donuts. Because you're used to the term dozen, you know what I'm saying is that I have 12 of whatever I'm talking about. If I asked you if you have a pair of something, a pair of shoes, a pair of apples, whatever I'm talking about, if I say a pair, you're going to know that I'm talking about two of something, okay? The mole is the very same thing, okay? Except it's a number that we're not familiar with. A mole of anything, so if I were talking about a mole of apples, is 6.02 times 10 to the 23rd. Okay, so this is a very important number going forward, one you're going to want to remember. It's 6.02 times 10 to the 23rd of whatever you're measuring. Okay, now, if you say that as an exponent, it doesn't really get the point across, but if we put all of the zeros behind it and write that whole number out, you can see that this is a huge, huge number. So when I'm talking about a mole of something, I have a whole bunch of whatever it is I'm talking about. Okay, this number has a name. It's called Avogadro's number. It was named after a guy named Avogadro. And what we're going to use the mole for is to measure elements, compounds, and molecules. Okay, so a mole, if I'm talking about atoms, a certain element, a mole is 6.02 times 10 to the 23rd atoms. If I'm talking about covalent compounds, here's some vocabulary you should keep in mind. There's a different terminology we use for covalent compounds and ionic compounds. If I'm talking about a mole of covalent compounds, I'm going to say I have 6.02 times 10 to the 23rd molecules. And if I'm talking about ionic compounds, I'm going to say I have 6.02 times 10 to the 23rd formula units. Okay, so formula units are what we use for ionic compounds. But whatever I'm talking about, if I have a mole of that substance, I have Avogadro's number of that substance. Okay, now if you remember back to first semester when we were doing truth tables and conversions, we can use Avogadro's number as a conversion factor to solve mole problems. What we're going to say is we've got 1 mole of X is equal to 6.02 times 10 to the 23rd of whatever X is. X can be atoms, molecules, or formula units. So let's look at some examples. Okay, example number 1. How many sodium atoms is in 3.12 moles of sodium? Okay, so just like we did in the past, we're going to want to write down our given, our unknown, and our conversion. This just helps us set these things up right, okay? Those of you who got used to this method in the past did really well with it. Okay, so our given is always going to be the thing with the number. So in this case, 3.12 moles. I'm going to abbreviate moles as MOL, moles of sodium. All right. Our unknown is the how many. So for our unknown, we're looking at for atoms of sodium. Okay, for our conversion number, conversion factor, what I want you to start remembering, getting through your head, 1 mole of sodium is equal to 6.02 times 10 to the 23rd atoms of sodium. Okay, so we're going to set this up in a truth table like this. We're going to start with our given. Our given is 3.12 moles of Na. All right. Then we have to use our conversion factor. So we've got to look at our conversion factor and decide how we're going to put this into this truth table. Okay, so if we look at this conversion, because moles are here, we want moles on the bottom. So it's going to be 1 mole of sodium on the bottom, okay? And then atoms is going to go on top, so 6.02 times 10 to the 23rd atoms of sodium. Now when we plug this into our calculators, we are going to multiply the 3.12 by 6.02 times 10 to the 23rd. This is where it's really important. Remember last semester we spent some time making sure you knew how to plug this into your calculator. So if you've forgotten how to plug in exponents, now is a really good time to figure that out again. If I plug this into my calculator, I get 1.8782 times 10 to the 24th. Now, sig figs are still going to be important this semester. So if we look at our original number, we started out with 3.12. That number has 3 significant figures in it. So our answer can have 3 significant figures. So we can have this 1.87. We need to look at the next number for rounding. Okay, so we're going to round this to 1.88 times 10 to the 24th. Our units are going to be atoms of sodium. Okay, so now you've done your very first mole conversion problem. Okay, so let's look at another example. Example number 2, how many moles is 9.21 times 10 to the 25th molecules of carbon dioxide? Now notice carbon dioxide is a covalent compound, CO2, so we're going to use the term molecules. Same type of problem though. If we write down our given, our unknown, and our conversion factor, our given is the number in the problem, so 9.21 times 10 to the 25th molecules. Now make sure that you don't abbreviate in a way that you get confused. Okay, moles and molecules. If you get them mixed up, you're going to put your problem together incorrectly. Our unknown for this one is the number of moles. Alright, our conversion factor is going to be the same thing. 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay, so let's set up our truth table. In our truth table, we start with our given 9.21 times 10 to the 25th molecules. Okay, so that means if molecules is on top here, I want molecules to go down here. So now I'm going to put molecules down here, 6.02 times 10 to the 23rd molecules is equal to 1 mole. Then I'm going to plug this into my calculator, making sure that I use the right button for exponents. I'm going to plug in 9.21 times 10 to the 25th divided by 6.02 times 10 to the 23rd. That gives me an answer. My calculator tells me 152.99. Again, I have 3 sig figs in my initial given, so I can have 3 sig figs in my answer. So my answer to this problem is going to be 153 moles of CO2. Okay, let's do one more practice problem. Example number 3. How many formula units is 8.95 moles of sodium chloride? Sodium chloride is an ionic compound, so we're using the terminology formula units. But we're going to set the problem up the very same way. So you've got given, unknown, and our conversion factor. In this case, our given is 8.95 moles of sodium chloride. Our unknown is formula units. I'm going to abbreviate formula units, FU. And our conversion factor is going to be 1 mole is equal to Avogadro's number, 6.02 times 10 to the 23rd formula units. Alright, so let's set up our truth table. We put our given up top, 8.95 times, oops, excuse me, no times anything, 8.95 moles. So our moles is going to go on the bottom, 1 mole here, 6.02 times 10 to the 23rd formula units here. Moles cancels out. So if we plug this into our calculator, 8.95 times 6.02 times 10 to the 23rd, my calculator says 5.3879 times 10 to the 24th. So I, again, 3 sig figs, so I'm going to round this to 5.39 times 10 to the 24th formula units of